Hi, let's continue with our next section, 5.3, normal distribution, finding values. Alright, so in the previous sections, we worked with some bell-shaped curve, and we used the mean and the standard deviation to find the probability of something happening. Well, what about when we want to find the value that we're working with? Meaning we have some bell-shaped curve, and we have some mean, and we want to find, we know the probability, we know percent that corresponds to, but we don't know what this value is. That's what this section is about, finding that value, and you're given either the answer, the actual probability, or when you're given the z-score. So with those two pieces of information along with the standard deviation, we can find what that stopping point is. Alright, let's continue. Finding z-scores. In the past section, you were given a normally distributed random variable x, and you found the probability that x will lie on the interval by calculating the area under the normal curve for the interval. But what if you're given the probability and you want to find the value? So, in a sense, reverse. Our calculator functions, to find the reverse of it, we're going to do same command, second, and then vars. But now we want inv norm. And I think that's the third or fourth option. We want to enter these pieces. The percent, meaning the answer, always in decimal form, our mean and our standard deviation. And we can find the z-score that corresponds to it if we have the probability. So that's another way to just enter it. Just the probability and you get a z-score. For Excel, you want to enter equal sign norm.inv. I believe it's .inv, yeah. And then you want to fill out 3 pieces of information. Your probability, your mean, and your standard deviation, and that will give you the value x. Similarly, if you have the probability and you want to know the z-score that corresponds to it, you can put equal sign, and then one of the options will be .is.inv, and you enter the probability, and in return you'll get the z-score. So let's do some examples. Find the z-score that corresponds to the cumulative area of 0.3632. So we know the answer. All this is saying, you don't have to draw this out. For some bell-shaped curve, our answer is 0.3632. You want to find the z-score. What is the z-score? All right. In Excel, you want to enter norm.is.s.inv and your answer. And in your calculator, you want to enter inv norm and your answer. And that will give you the corresponding z-score. So we see that our z-score is 0.34991. And it continues and you round to whatever answer your question wants. 2. Find the z-score that has 10.75 of the distribution's area to the right. Alright, this one we might have to draw. So we want the z-score that has 10.75 of the distribution's area to the right. So we want to find this piece that is 10.75%. Remember to always change it to decimal form. Move the decimal to the left twice, so that'd be 0.1075. Alright, well, if we want the value to the right, we have a problem, because it's going to give us the z-score corresponding to the value from 0 to the left. So let's go ahead and subtract. We have to do some busy work in between. So I do 1, because I know the whole probability is equal to 1, minus the percent we want. So 0.1075. And that gives us 0.8925. You enter that in your calculator, and that's the percent that corresponds from here to 0, which is the same as saying the right 10.75%. So we enter our command with our probability, and our answer is our z-score, meaning we have a z-score of 1.23 or 24. All right, another way to see percents is with the verbiage of a percentile. So things you'll see, recall what that means. A percentile corresponds to percents as blocks, but just think of it as a straight up percent. That wouldn't be incorrect to think of it that way. Now, quartile means in fourths, right? So you will want things like 25% would be one quartile, 2 quartiles would be 50%, 3 quartiles, 75%. You can also see decitiles, and that means by tenths. So 1 would be 10%, 2 would be 20%, and so on. So in this example, we're asking for find the z-score that corresponds to a percentile. So a percent. 5th percentile. So if I have a value, I want to know what corresponds to 5%. What is this x value that corresponds to 5%? We weren't given any more information, so let's assume we have a standard normal value with a mean of 0 and a standard deviation of 1. Alright, if so, you will enter it this way. For a calculator, you enter your percent, followed by your mean and your standard deviation. For Excel, same way. You enter your percent in decimal form, your mean, and your standard deviation. Please remember to always change your percents to decimal. And this is your answer. So because we're inside our normal, that also corresponds to the z-score. 2. Find the probability of 50%. P50, 50% percentile. All right, so I don't think you have to use a calculator if you think about it enough. So we have a mean of 0 and a standard deviation of 1. You want to find the probability of 50%, which is half of it. So working with z-scores, that's z0, right? But however, we can still enter in a calculator in Excel and we'll get the same answer. Why is that? Well, I think we just explained it. And then we have a couple more examples. I believe you can get it from here. Now, when you're working with percent, it's pretty easy. But when you're working with z-scores, it requires a bit of algebra. Transforming a z-score to an x value. To transform a standard normal to an x value in a given population, use the formula. So actually, this stems from your z-score formula. Your z-score formula is mean minus, isn't it x minus your mean divided by standard deviation? Well, if you solve for x, so let me walk you through the algebra, you can totally ignore this. Multiply by standard deviation. So we have standard deviation times z equals x minus m. We want to get x by itself, so let's add m to both sides. And we get sigma times z plus m equals x. And that's what we have here circled as well. So what we're doing is we're trying to find that x that corresponds to a value given the z-score, the mean, and the standard deviation. Let's do an example. A veterinarian, that word, records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weight x corresponding to each z-score. So 1, we have a z-score of 1.96 and a mean of 9 and a standard deviation of 2. Well, I have a formula. Our formula is x equals mean plus sigma times z times sigma. Let's enter these values. Our m, which is 9 plus z, my z is 1.96, times 2. All right, we call order of operations, so you first have to multiply 1.96 times 2 is 3.92. And then we add 9 and get 12.92. And that's our answer. That's our x that corresponds to that z-score given the mean and standard deviation. Let's do one more. Let's do 2. Okay, we have our formula. C is equal to, x is equal to. X is equal to, let me highlight it just so we have it handy. It's right here. X is equal to mean plus z times sigma. So we get x is equal to, for 2, we have a z of negative 0.44. We still have the same mean given. We're given a mean of 9 pounds and a standard deviation of 2. All right, so I have a mean of 9 plus, let's do the multiplication in parentheses. We have negative 0.44 times 2. And we enter that in our calculator. Negative 0.44 times 2 is negative 0.88. And we're going to add that to 9. So plus 9, we get 8.12. And that's the x that corresponds to that mean and standard deviation. So again, what this is saying is, if I have some bell-shaped curve with some mean, I'm trying to find the value of the curve. I'm trying to find that x value. Let's do an example. Scores of the California Peace Officer Standards and Training Tests are normally distributed with a mean of 50 and a standard deviation of 10. An agency will only hire applicants with scores on the top 10%. What is the lowest score an applicant can earn to still be eligible to be hired by the agency? Let's draw our bell-shaped curve just so we can understand what we're looking at. So we have a mean of 50, and also a standard deviation of 10. And I want to find those applicants that are on the top 10%. Remember, the whole thing is 100%. We want the top 10%. So we can even be a bit more clever with this. If this marks the top 10%, wouldn't it just be the 90% of it? And if it seems silly, we can also do the math. Remember, our calculator only calculates from 0 to a value. So we want the opposite of it, so we have to do some work. We have to do the complement, since our calculator only works from left to right. So we do 1 minus 0.10, which gives us 90, which will make sense that this is the 90% mark. All right, so this is the way you can enter into your technology. You enter your percent, followed by your mean, and then your standard deviation. And that's going to give you the value that corresponds to that. So your solution is 62.81. So what are we saying? What is the lowest score an applicant can still earn and still be eligible to be hired in the agency? So we can say the lowest score an applicant can earn is 62.81 or 82. All right, we learned two main things. In order to help you keep your ducks in a row, here's an outline I would like you to fill out in your time if you'd like to help you keep track of your information.